This video is all about the dangers of radiation. Radiation can cause harm in two ways. The first is contamination. This is the unwanted presence of radioactive isotopes in or on materials or bodies. This often includes inhaling or ingesting radioactive materials. The second is irradiation. This is when the radioactive source is not in the body, but that body is exposed to the radiation. An example of this would be standing near a gamma source without touching it. These definitions come up a lot, so make sure you can recall them. Let's go into more detail about what actually happens when ionizing radiation comes into contact with living organisms. One outcome is tissue damage. This is the result of the radiation ionizing atoms in cells, which can cause them to stop functioning and die. This outcome is often produced by high-energy electromagnetic radiation, like X-rays and gamma rays. Alternatively, mutation may occur. In this scenario, the cells do not die, but the DNA in the cell is ionized. While repairing this damage, the DNA may mutate and replicate uncontrollably, forming a tumor. These effects are, of course, things we want to avoid, but radioactive materials are still very useful in industry or medicine. There are precautions we can take to minimize the risks. Increasing the separation between the user and the source reduces the intensity of irradiation and reduces the chance of contamination. Reducing time spent near the source decreases the total amount of radiation received. Shielding reduces the amount of radiation or radioactive material that reaches the user. This could be lead clothing, suits that prevent the inhalation of materials, or storing the source in a lead-lined box. Byproducts of nuclear power production often have long half-lives and could remain a risk for thousands of years. One solution to this is a form of shielding. The waste is just buried in the ground. Even gamma is unable to penetrate large amounts of earth and rock. When confronted with a precautions question in your exam, always refer back to the properties of that type of radiation. For our worked example, we're going to tackle a 6-mark question. A lot of students find these intimidating, so we'll talk through how they are marked. The question asks us to compare the risks to a person of contamination and irradiation from an alpha-emitting source. The examiners use a list of statements, often called indicative content, to mark a 6-mark response. This is basically them saying, if your answer includes this content, it indicates you know what you're talking about. It does not mean that if you write 6 of these statements down, you will gain 6 marks. For this question, the indicative content includes statements on irradiation, such as defining irradiation, stating properties of alpha, and explaining how this could cause harm. Statements about contamination are also required to access those top marks, such as defining it, referring to alpha's penetrating power again, and explaining the consequences and subsequent damage of alpha contamination. The answer is categorized into one of 3 levels. A level 1 answer makes 1 or 2 of the indicative content statements, but doesn't link them as an explanation. A level 2 answer makes a few more statements and maybe links a few of these. A level 3 answer makes a large number of indicative statements, and the answer has a logical overall structure. Okay, for our answer, a good place to start would be to compare the definitions of contamination and irradiation. An examiner will notice 2 correct definitions and the use of whereas to link the 2. Next, it would be sensible to go into further detail about the dangers of irradiation. We mention alpha's penetrating power and refer explicitly to irradiation. This sentence evaluates both how alpha irradiation is not so dangerous externally, but how alpha's ionizing power still has risks associated. This linking statement pushes the answer closer to a level 3 already. The final step is to evaluate the risks of contamination. First, we address the main risk, which is that alpha particles cannot leave the body once inside. Next, we compare to irradiation, making a link, stating that contamination does cause damage internally. Following this thought train, we conclude by saying that alpha contamination could lead to organ failure or mutations leading to cancer. This answer would gain 6 marks as it includes a lot of indicative content and makes links throughout the answer. In this video, we have defined contamination and irradiation. Either of these can cause tissue damage and mutations in DNA which lead to cancer. This can be prevented by using shielding, getting further from the source, or being near it for less time. Don't forget to check out all our other fantastic revision resources at Save My Exams.